So in this video, we'll do a little bit of an overview of Linux and sort of some of the history behind it and how it started to used in embedded systems. If you want to trace the story of Linux and embedded systems, you can start by talking about the TiVo. So the TiVo debuted in 1999, just before Y2K, where this was really one of the first cases that we had Linux running on what we'd call an embedded device. So not really a computer anymore, now an actual product that a user would buy. So the TiVo was one of the first products to do time shifting of TV. So allow you to record live TV on a hard drive and rewatch at a later time. So it was one of the first applications that really the hardware was advanced enough to run Linux. And because of all the things that the box needed to do, the storage aspects, the video aspects that were already built into Linux, it made a lot of sense to leverage Linux as a part of the implementation. So fast forward through to present day, as of 2017, there are 2 billion devices running Linux. So really the early 2000s have just been an explosion of products that are using Linux as the embedded operating system. So why would you want to run Linux on your embedded operating system? Part of the reason that the book Mastering Embedded Linux Programming discusses is due to Moore's Law. So Moore's Law says that the capabilities of processing roughly doubles every 10 months. And what this means is that embedded systems and really all computing platforms have had exponential growth in terms of CPU processing capabilities. So the additional burden that's associated with being able to run Linux is really less of a hurdle in every year than it was the previous year. So in other words, as our computing platforms for embedded have gotten more and more powerful, it's become easier and cheaper for us to include Linux as a part of the embedded distribution. So why would you want to use Linux if you can? Because there's a lot of functionality that's built into Linux that there's really no reason to recreate yourself. And if you were to recreate yourself, the amount of engineering effort that you would need is huge compared to what you could do if you can leverage the work that's already done by members of the community that have similar needs to your embedded product. So for instance, supporting for scheduling threads, and scheduling that's happening in the operating system, network stacks, so anything related to TCP/IP or web, which is usually a pretty common feature of embedded, USB and Wi-Fi, Bluetooth, all those hardware standards that are very popular on embedded products. There's levels of support built for all of that into Linux. Storage, so the ability to record to flash or to hard disk drives. And there's a long list of functionality that is common and has been implemented in Linux, has been tested and used on platforms for a very long time. So being able to leverage that in our embedded systems is a big bonus. Linux is already ported to a wide range of architectures. So for instance, if you want to use ARM, due to cost constraints or the fact that you can really hit your price targets with that particular platform, there's already Linux ports available and you can already run ARM. So there's several other architectures like that we can leverage in embedded systems and are already supported by Linux. It's open source and modifiable. So what this means is that if you find a problem that's specific to your individual device, you don't have to go try to convince some operating system manufacturer or developer that they need to fix this problem for you. You have the source, you can change it yourself, or you could find experts that know the part of the source that you need changed and have them change it for you. So that's a pretty big benefit in terms of embedded systems development and the freedom that you have and the flexibility you have choosing Linux as your operating system. There's also an active community. So for every project that you use, every open source component that you use, there's a community of people on mailing lists that are experts in that particular software that are available to help answer your questions and help get you unstuck if you're stuck on some specific problem with that software. And there's no vendor lock-in. So because it's an open community, there's lots of different people participating from both business and personal perspectives. There's no one company that's in charge of controlling the roadmap for the software. There's no one company that you're beholden to in terms of what features are going to be available and what you can do with the code that's available from Linux. It's kind of all up to you, since you have access to the source and can make the modifications yourself if needed. So some of the things that you need to consider before you decide if Linux is the right solution for your hardware or your embedded system design. It will need a more powerful processor, probably more storage and more RAM than if you were just going to do a very simple embedded design. So some of the designs that you've done already with simple microcontrollers, you might not really have the opportunity to run Linux just based on hardware limitations. So for Linux, you will need a 32-bit processor. You'll need roughly at least 16 megabytes of RAM and 8 megabytes of flash, which every year becomes less and less of a hurdle. It's much easier to find platforms that can support this level of flash and RAM availability. You also need a memory management unit, so a dedicated piece of hardware on the device that manages memory for you. For all practical purposes, there are ways to get around that, but it's much easier if you have an MMU. So those are kind of the hardware limitations that you need to have in order to know that you'll be able to support Linux. You're going to need a set of engineers that have some abilities in Linux development, so that will be you after you complete this course. And there may be some real-time applications where Linux is not a great fit, or where you need to do some custom tuning to the kernel to bring in real-time extensions. And that's kind of outside the scope of this course, but these are some of the things that you'd need to think about in the context of a specific development to know if Linux is the right platform. So who are the players in Linux software development? Who is kind of responsible for bringing new releases to you, or for adding support for the platforms? So first, there's the open source community, which is really just an alliance of developers that run the gamut of different goals, desires, including not-for-profit companies, academics, and also commercial companies that are all participating in development of Linux as open source software developers. And there's generally a group of open source developers for every set of applications. So the individual applications that we'll talk about as a part of the course, the build tools that we're going to use to build the embedded Linux distributions. Behind every one of those groups, there's a set of individuals that are developing that particular software. And that's the group that's going to have the experts in it that you're going to be able to reach out to with questions. Also the group that you'd go to if you wanted to make a change, to discuss what your change is and ultimately submit patches for their review and approval to be added into the software. Then there's also CPU architects, SoC vendors, board vendors. So these are the people that are making the hardware that's going to run Linux. And a lot of times what you'll see is they'll try to make it as easy as possible for you to incorporate Linux. So they'll create what's called BSPs, or board support packages, that kind of bundle all the things that you need in order to be able to run Linux on their particular hardware, and create a reference design for you so it's easier for you to get started running Linux on their hardware. So more reasons to run Linux. If you're using software, there's essentially a shelf life, right, where there are. So one of the benefits of using Linux is having this dedicated community behind you. It's too much for you to be able to keep up with every single software package, keep up as new packages are developed, as new compiler versions come out. You want to be able to leverage all the work that's being done in the community to stay up to date. And bugs are a fact of life. They're going to happen in every software application. You want to be able to bring in the changes from the community that fix bugs as easily as possible, and to be able to keep up with that without a lot of individual work from your software development team. So the BSPs that I talked about previously, companies might start with one particular version of the kernel for their BSP implementation, but they might not necessarily keep that up to date going forward. Like they might have an example that they did when the hardware was first developed, And maybe now you're going to use the hardware and it's 2 or 3 years later, maybe their BSP is still referencing an old version of the kernel, for instance. So using Linux allows you to do your own work to kind of customize what they've given you and bring it up to date and stay up current with the most recent Linux applications or Linux kernel, with especially with fixes for security bugs. And so part of the reason that it's important to keep up with security issues, you may have heard of the Heartbleed case from 2014, and this was a bug in a very popular OpenSSL library where OpenSSL is used to secure communications that happen over the internet. And even to this day, there are, or as of 2017, there was a study that was done that said almost 200,000 devices are still running in the field with this bug. So part of the reason that they were running with this bug is that they weren't able to make it a part of their development process to incorporate updates easily. So while that's something that the Linux community is going to allow you to do, there's some work you need to do in order to do that, and there's some tools that can help you keep up to date with that, like Boulder or Yocto, that we're going to cover in this part of the course. But the main thing to know here is that being a part of the community and keeping up with the new releases that come from the community can help you solve this problem in Linux in a way that it wouldn't if you were trying to roll your own distribution and responsible for every single part of the process.